a phenomenon that still goes out in my country. Maybe nobody in your part of the world still plows, but in my part of the world, I still have guys that plow. So you go out there and you put that layer of residue in the soil so it can get broken down and be ready to work for you next year, right? So you got this tilled soil, and you've got this residue layer in there that's got all kinds of pore space that's going to hold on to all that water for you, act as a sponge, they tell me. Water's going to stand down there in that, or sit down there. What does water do, sit or stand? In that residue layer. But what we've done is sealed it off with that conventional till fluff on top. We've created an anaerobic condition right here, a habitat down there without any air. And our little soil livestock guys need air too. They're animals, they need oxygen. So what happens the next spring after you've plowed that under in the fall? Wheat farmers, you're coming in the spring and you're going to bring that back up. Looks just like it did when we put it down there. So why not leave it on top and use it? Okay? So we'll get Dan started here.
Are there holes in the bottom?
There are holes. There are.
Yes.
Now, Bud has done it without holes, but not me. Good question. Okay. Excuse me, we're going to move this back out of the way so Dan can go here.
I still want to be able to see this sign here, which I can maybe move over.
Okay. One thing I failed to mention when we were talking before about the fluff. What is soil made of? Mineral, about half of it's mineral, half of it's air, or a quarter of it's air, and a quarter of it is water. So we compact our soil, and all we're doing is pushing out the pore space, pushing out the area where the air and the water should be. So this is bulk density. When someone talks to you about bulk density, now it is the weight and the volume. So I got two little volumes here, same size, but feel the weight difference. Okay? Because there's more mineral there. When you compact your soil and you get more mineral in a volume, it gets less airspace. Less airspace means less room for water. Okay? I wanted to explain that, and I forget to tell you that. All right, Daniel, I will turn your water on.
Okay, it's on. You just have to adjust. Okay, but if we can look at the picture again here. And guys, this says it all. This picture is 12 years old. I took our state conservationist, Steve Chick, for a tour around Madison County. I'm from the northeast part of Nebraska. And this is Nora Crofton D-slope soils, our predominant highly erodible soil, 6 to 11% slopes. This is off of my farm after 11 years of no-till. And we went out into the field, we dug up a spadeful of this Nora Crofton D-slope stuff. We went across the road into the neighbor's field, which at that point in time was conventional yet, and we dug that up as well. And you can just see, you know, right here by the aggregates that slough off. You know, we're talking the major benefit to us as farmers is going to be the amount of water we can put in our soil. If you're in an arid climate and you get 16 to 18 inches a year, if you can harvest 3 more inches of rain by having good soil structure, that goes directly to bottom line, okay? The aggregate stability, the integrity of those aggregates to maintain their pore space as that runoff event or that rainfall event is occurring is what it's all about. And look at those aggregates that slough off of this no-till soil. Okay? And look at the size of the aggregates that are in the tilled soil. This is beat to death by tillage. Tillage needs pressure to move disc blades and shovels, and it's just smashing the air out of that system, just as Kathy talked about. So the bulk density of these two clods, if you will, spadefuls, there's probably about 20% more soil in this sample than there is in that sample. And the difference is that 20% is the airspace, the pore space that we need to let the air out so the rain gets in and to store that water in that rainfall event. One of the other things, you know, soil health, soil quality, you've heard, Jill and everybody talk about the soil health and the soil quality. And out in the field, what we're doing out there, it all relates to good soil structure. So this is what it's all about, soil quality. Look at the roots coming out of that system. With the pore space in there, the roots can grow faster and obtain that girth and be more productive. Again, as Kathy was pointing out, in the sand, silts, and clays, why do sands take water in faster? Because they're big granules and there's pore spaces. That's why you want it right here. Okay, Bud, can you see the raindrop? Guys, this, as Kathy pointed out, this is the culprit. We need the rain. That's the basis of our farming operations. We provide the nutrients in the seed, and Mother Nature provides the rain. But if the soil isn't covered, you're going to see that raindrop bombard these soil aggregates into smaller particles. They become a liquid suspension, move to the pore spaces, plug them up, and that is when the runoff event occurs. We're going to, this shine here, we're going to look at that here as we begin the rainfall simulator. Okay? So, what we've got here is we have got one of Mother Nature's best. This is a long-term prairie soil, native, never been tilled, so it has been literally growing from the time the ground warms up till the time it gets so cool that you can no longer have the growth, okay? And what is that? That's an extended period of biological activity. You heard Jill talk about the fungal mycorrhizal systems that colonize the soils. That's what this is all about. The soil glue, the glomalin that leaks out of these fungal systems that only survive and flourish when you're not disturbing that soil profile. That's the key to this. So this is Mother Nature's best. Good residue cover to prevent the raindrop splash, good aggregate stability to maintain the pore space, and good infiltration. Beneath this soil pan, we have harvested that prairie soil. We're going to leave that in a bare pan just to see if that aggregate stability, that integrity of the soil structure makes a difference there. Now what do you see here? These are the same soil types. This is a little more organic matter. Organic matter indicates that you should have a better soil structure. So we go from this pan to the control, which is the bare soils. Now, for those of you who grew up running a tillage implement to prepare the seed bed, man, this is what it's all about. Look at that nice not loose seed bed, friable. That field cultivator just beat all those soil particles into a nice fine texture, and you come in there and plant and just do a great job. We all grew up doing that because that's what we had. So this is our control. It's a bare soil where the raindrop impact is going to be maximized. We'll predict that it should yield the most. Here is what we call a D-. This is 30% residue cover. On average, this is the amount of residue that you need to maintain on the soil surface to maintain eligibility for federal farm programs, okay? A D-. You can't do any worse than this and still participate. And here, again, conventional soil, 30% residue cover. And here, underneath here, is the same conventional soil, but what we're simulating here is just the first year that you park the tillage implement. You leave the residue cover on the soil surface to deflect the raindrop impact and allow the soil particles to maintain their integrity. It's still a conventional soil. There's smaller soil pores, but the residue is going to allow this soil to maintain that. Are we taking those off? Oh, we do. Okay, we have to switch sides? All right. I kind of wondered about that.
High-tech farmer stuff.
And what we're doing here, folks, is we're putting these above the trays so that we are measuring exactly the amount of water that comes off of the pans and not any extra from the simulator. Okay, so Okay. All right. We're going to make it rain here, folks. I think that's good, Jack. Okay, so the first thing that we're going to see is that little shiny apparition on the surface of that field. You know, you just left that field with your field cultivator doing the final tillage pass, and here comes a pop-up thunderstorm, and you get a ½ inch of rain really quick in 20 minutes. And before you're a mile away, you can see that hillside already turning shiny. You guys recall seeing that? Okay, and that's the signature right there. The raindrops are bombarding those soil particles that have no structure, that have no glomalin, no soil glue, that helps keep them in an aggregate and preserve the soil pore. Thus, the sand, silts, and clay separate, and the clay particles, the smallest ones, float over to the pore space, plug it up, and then we have a runoff event started. Rain gauge in the middle there. Now I have a disclaimer to file here. This is not like the deal where you go to check the cows with two buddies and you're in the pickup and the bottle of a schnapps. It's a cold day and it's passing back and forth. Just because you're the guy in the middle doesn't mean you get twice as much, okay? You're still passing it back and forth. The other advantage is you don't have to open any gates, but we are just simulating the rainfall. And as you can see, boy, it hasn't been just a few minutes, and we're already getting some runoff. You see the soil surface is plugged, the runoff events begun. Now, you remember going into NRCS in the mid-'80s after the 1985 Farm Bill and having them figure out how much residue you needed to leave on the surface of your soil in order to qualify. That's the universal soil loss equation. And that predicts, I'm going to move here, bud. That equation predicts, based on the soil type, the slope, and the amount of residue, how much you need to maintain. It says the control, or bare soil, will yield 100% of residue, or runoff and sediment, and the 30%, which is our D minus, will, with 30% cover, cut that erosion in half by 50%. And as with yesterday with this soil type, this is a highly erodible soil. It's yielding almost as much as the bare. So that's, you can understand the D minus. You know, there's no soil cover, so everything's exploding that soil surface, the soil particles, and there's no soil biology. Also look at the back splash screen. You can see how that raindrop is literally exploding those soil particles. They're flying up and splashing on the back. That also is the reason that the residue covered trays are on the outside. We would have rainfall shooting that erosion and the sediment, the runoff off the side instead of being collected. Okay, 100% residue cover. Simply parking the tillage tool for the first time on that conventional soil. 70 to 100% cover in the soil loss equation says you'll reduce your runoff by 90%. And you can see that happening. Now, in the back, behind this row of runoff jars, you'll see another row of jars. That is the infiltration measurement. And you would expect that to be pretty much inverse. If it's not running off, it's got to be going somewhere, and that is into your soil profile. And this is new. It's a neat part of this simulator. As you can see with Mother Nature's best, good soil biology, good soil blues, residue cover to dissipate the impact of the raindrop. It's going right on through. And this is what we're talking about with that, you know, especially in the low rainfall areas. If you're in the arid western part of the state where you're looking at 12 to 16 inches a year, and one of your rainfall events that spring is a 3-inch thing that blows through, and you only get ½ inch of it, and you let 2.5 go down the drain, that's about 12 to 25% of your yearly preset. that you just lost out on. We'll talk more about what that means in terms of yields.
The other thing that Dan Perdue talk about, because he comes from the area that gets some rainfall, I come from a pretty dry area, so we have more of a wind erosion problem. So when you have a simulator out west of Nebraska, they're saying, well, yeah, but we don't have water erosion. But if you're from an area that has a lot of wind erosion, you know that when you get these rains like this, and it packs that soil and you get that crust, and the next day, you know, it gets hot and it bakes that ground and then the wind comes up. And it blows that topsoil out. You can't even get in there to do some emergency tillage because it's too wet and then it's blown away. So this is what happens when we let that raindrop beat that soil into that crust. You still have to worry about the raindrop even in the wind erosion areas.
Yeah, it's that double whammy. You'll lose it both ways. And it's a stark contrast where Kathy, Mark Watson, those guys measure a good rain in hundredths, and in the eastern part of the state, we measure it in inches. You know, we talked about, that was a good rain, they got an inch. And I call out to Mark and Kathy, we got 23 hundredths last night. Good rain. That just underscores how important it is to harvest every little bit that you can. So, you know, I think we've got enough run. We're going to shut this thing off.